Welcome you all for Introduction to AWS Solution Architect session. So in this session, the agenda or what we have in this session is introduction to the specific training. We're going to talk about what this course covers all about. And we'll also talk about AWS, introduction to AWS services and introduction to cloud 101. That's kind of what the key takeaways of this session. So if you have any questions, any point in time, feel free to stop me there and post your questions. And you can also use chat box to post your questions, but while presenting, I may not be looking at the chat. So probably I'll circle back onto your questions in a short while. So I've been in the industry for about 15 years. I've done many roles as a system administrator and network administrator and cloud architect. I'm also certified on AWS Solution Architect, and these are some of the certifications which I carry, and these are my core skill set which I carry. Additionally, which is not documented over here, is I'm also a CCIE in data center, that is Cisco certified internetworking expert on data center technology. One of the prerequisites for this course is you have a basic understanding of Linux command line, or if I have to put it in this way, have some basic operating system knowledge. If you don't know anything about Linux, does not stop you to attend the session, but we'll do the level setting, or I'll run you through the command line and the configurations around Linux when the module comes in. All right. So this session is designed for audience who are beginners, who are developers and architects who are trying to host their applications in the cloud, or DevOps professionals. In the cloud, we also leverage DevOps tools in order to deploy your applications. So this is for somebody who is trying to use cloud infrastructure and implement this cloud infrastructure or deploy the cloud infrastructure using DevOps technology or DevOps culture or DevOps tools. So somebody who is trying to migrate their on-prem data center to the cloud, and professionals who are trying to master application servers and network security. This is for the target audience. What is the overall objective of this course? So it is to plan and deploy dynamic, scalable, highly available, fault-tolerant application on AWS. So we're going to see how to host applications in the AWS infrastructure, which are dynamically scalable. So when there is a more need of resources, it can scale out. And when you have less need of the resources, it can scale in. Highly available and fault-tolerant application on AWS. Migrate complex multi-tier applications on AWS. Basically, from a developer standpoint, you may have multi-tier application. So you may have web tier, application tier, and database tier, 3-tier application or 2-tier application. So how do you migrate them from the single standalone architecture to microservices architecture in AWS? Design and deploy enterprise-wide scalable operations on AWS and configuring cost control strategies. Somebody who is in the finance of your IT organization will be really interested. How are we going to fund this? How are we going to expense this? So AWS services. So how do you optimize the AWS services cost strategies, which we're going to discuss? and set up a suitable utilize of AWS architectural best practices. So far, we have been hosting our application in the on-premises data center, but there is a shift in the paradigm. Today, world is moving towards the cloud. The reason why world is moving towards the cloud or companies are moving towards the cloud is if you talk to CTOs of the premium or Fortune 500 organization, one of the top priority for them is exit their data center. They don't want to manage their data center anymore. They don't want to manage their data center anymore. They want to host their application without managing the data center, because when you manage the data center, you need to manage the electricity, space, infrastructure, cooling requirement, hardware, software, and also you need to calculate the peak requirement. For example, whenever you try to design an on-prem data center, you would build the data center for your highest peak requirement, wherein that highest peak is required only in certain seasonal requirements. It is not required always. So cloud computing enables you to stop thinking about your infrastructure hardware and instead think of it as it is as a software. So something similar, what you're trying to do over here is we use our mobile phones, data services. We are not managing or mobile. We are basically using the mobile services, and we are not managing anything onto your mobile infrastructure perspective. You're just leveraging services by paying a subscription cost on a monthly basis. So similarly, if I have to give another example, for example, we are using Office 365 Outlook, right? Earlier, we were managing Exchange servers in our data center, but today, Office 365 is a cloud offering by Microsoft. What they try to do is they give users, host users on the cloud, and the enterprises need to pay on a recurring cost. Enterprise need not have to manage their Exchange server, hardwares, take the pain of taking care of hardware replacement and upgrades and all the stuff. Everything is taken care by Microsoft. All you're trying to do is leverage the email services from Microsoft. So cloud computing is all about, you need not think about infrastructure hardware. All you need to think about what is your need and how basically all you need to think about is I have an application, I need to deploy it, and you have an infrastructure available in the cloud to deploy your application. It is as simple as that. With that, I would like to take if you have any questions so far. And I would like to hear from Imad and Kumar and Lisa, your quick background on the cloud. Do you have any background on the cloud? Do you guys, what's your background? Do you have any experience on cloud? Or what's your objective of the specific course? Why are you attending this course? The reason I ask this question is so that I can give you some examples around what you're working on, right? So Imad, let me come to you, Imad. Do you want to take a quick minute to introduce yourself and give some background?
Sure, Raj. So I have done my master's in finance and marketing. So currently I'm working as in a BPO organization. So one of my friends suggested me to get enrolled for AWS. Even I'm getting trained on Linux as of now. So I heard that Linux is the prerequisites to be a part of this AWS training. So that's where I'm in to get trained on this particular AWS Solutions Architect training. And even I want to know from your end, post which AWS Solutions Architect training, which all other courses I can get trained on so that I can get on a job and secure my position in an organization.
Sure. Thanks for that highlighting what in that. So I would be covering about what is the future roadmap of the certifications in the upcoming slides. But uh, end of the day, end of the session, you would have that insight, right? Let's go to Lisa. Lisa, do you want to quickly introduce us and talk about your background and also what's your
Hi, Raj.
Yeah.
Hello.
Yeah, Lisa.
Hello.
Yeah, I can hear you very well.
Yes, hi, Raj. This is Lisa here. So I had a question.
Mhm.
So post completion of the solutions architect training, this is on the associate level, right?
Absolutely right. Yes.
Right. So post this, if one wants to go ahead with the professional certificate, what needs to be done and what are the pathways for that?
So I'll hold on to that question, but you may have to take up the professional training program and then follow on take the certification on uh, AWS AWS certified professional training and certification. That's kind of the roadmap. But I would like to hear from you. What's your background and what's your expectation in the specific session or the specific training program?
Well, I come from HR background and excuse me. I come from HR background, and right now, since cloud is booming in the industry, so I thought I would switch over to cloud. And as AWS is the oldest one compared to Microsoft Azure and GCP, so that's why my plan is to take up AWS followed by DevOps.
All right. Thanks for that, Lisa. Quickly, let's go to Kumar. Kumar, do you want to unmute yourself and introduce us?
Hi, Raj.
Hey. So, Kumar, basically what I would like to know is what's your background and what's your expectation from the specific training program?
I have done my BE in computer science, and I'm just working in ITES sales. So I was expecting a career switch. So one of my friends suggested this course.
Oh, got it. So, the thing what I get is most of you are coming from a very fresh mindset or a background on cloud. So I take you as a beginners in the specific training program, and I would give some examples in the same direction. I think so far the examples or the analogies which I'm sharing, are you able to resonate them?
Yes.
Great, perfect. All right, thank you for the quick introduction. Cloud computing. There are three types of cloud computing. One is infrastructure as a service. The second one is platform as a service. And third one is software as a service. In cloud, the cloud service providers, when I say cloud service providers, it can be AWS, it can be GCP, it can be Azure, or it can be Oracle or anything. Any cloud providers offer three types of cloud computing. Infrastructure as a service. It's kind of basically, in case of infrastructure as a service, the cloud computing organization or cloud computing service provider, cloud service provider are offering you the infrastructure. What is that infrastructure? Virtual or physical hardware to host your operating systems, applications, and so on. When I say hardware, it can also come with, when I say hardware, virtual or physical hardware, I'm talking about CPU, RAM, storage, network requirement, and all those stuff. So basically it is giving you the infrastructure. And the next one we're going to talk about is platform as a service. So let's say you don't want to manage the operating system patches, upgrades, and you just want to manage your application. Then the next option what you have is platform as a service. In platform as a service, the cloud service provider will provide you a platform which includes hardware, operating system together. Hardware and operating system together. When you get, you don't have to take the burden of managing the operating system updates and all those stuff. All you need to worry about hosting your applications, hosting your application in case of platform as a service. But in case of infrastructure as a service, you are just given the infrastructure, that is hardware, either a physical hardware or a virtual hardware. You are responsible to install the software and you're responsible to install the operating system and its patches. Then you have software as a service. Software as a service is kind of a complete package. You don't want to take any pain of managing the hardware, nor software, nor the application. One of the example which I gave is Office 365. In case of Office 365, this is a software as a service. You're taking email as a service and using it. You're not worried about managing the Exchange server, Microsoft Exchange server for email and so on. What are the benefits of cloud? See, when, like I said, I came in from the data center background, right? When we build the data center, first thing, what happens is the ordering. And somebody who is from the finance background generally don't like the cost, upfront cost. So what we do when we try to build the data center, we gather the requirement and we basically, I did some bit of pre-sales work. When I say pre-sales, basically participating into the customer requirements and going back to them with a bill of material and solution design. In that case, we basically gather the requirement, how many servers they want to host, what is the network bandwidth requirement, what is the storage requirement. Then we basically provide a bill of material that this will be the cost to host your data center. And we also provide a prerequisite. In order to install this data center, you need to provide me power, cooling, racking, stacking. All these things have to be taken care by the customer. Okay. So once customer pays the bill for the server hardware and everything, the hardware is shipped to the customer premises, and after that we install it and so on. So we have customer need to pay the upfront cost. We call it as capital expenditure. Trade capital expense for variable expenses. So if you try to go with a non-cloud deployment, you have a capital expense. But imagine you are a startup. You don't want to, build a data center and manage the data center. All you want is to host your applications and have your customer use your applications. In that case, you would prefer to go with an operational cost. For example, my customer used my application for 30 hours and in the backend, 30 hours of services is being used by my hardware is being consumed. I pay for 30 hours. I need not have to pay or manage entire data center for those 30 hours. So we call it as operational cost. So it is something like monthly bills. I give you, if I have to talk about operational expense, our monthly bills, our electricity bill and current bill, gas bill, all that is an operational cost. Our groceries, these are all operational costs. What is our capital expenditure is we invest upfront, we buy washing machine, fridge, aquaguard, and all those stuff. These are all capital expenditure. We build our house. That is again a capital expenditure. All right. Perfect. So in case of cloud, your billing model is based on operational cost. However, there are other costing strategies as well. But if you pay upfront cost, you can get better discounts. If you know you're going to use the services or applications for, if you can guess the capacity needs, then you can pick those billing models. You can leverage the benefits from economic of scales. Basically, the cloud infrastructure is scattered across the globe, and wherever you have a need, you can host your application. Wherever your users are, closest to them, you can host your application. You did not have to stop guessing your capacity. Today, you may have 10 customers as a startup, but tomorrow you may have 100 customers. When you start building your application, you can pay for just 10 virtual machines. But tomorrow, when you scale for 100 customers, you can expand your application to be hosted on 100 VMs. So if you have to flip the other side, generally hosting the data center on premises, you have to guess the capacity and build the application, build the data center based on the peak capacity. Increase speed and agility. I said about data center product ordering. Generally, the time to go to the customer, they provide the requirement. We go back with the bill of material. They going back with the finance, taking approvals, then the ordering stage. After the ordering stage, shipping stage, it takes about months to build the data center. After shipping, racking, stacking, installation, then finally a sign off. Right? It is generally a time-taking process. But in case of cloud computing or cloud, all you need to do is gather your requirement, go back to your finance, take the approval, and host the application onto the cloud, and you would get monthly recurring bill. As simple as that. And in order to host your application, you can go global. Your application can go global in few number of clicks and in few minutes. You need not have to, the time from months to hours to months to weeks to hours is reduced to minutes. Instead of focusing on building data center, focus on what matters to your business and what matters to your customers. That's kind of the benefit of cloud computing. Any other questions, folks? Any questions? Are we good?
Yes, good to go. You can continue the same.
Fantastic. Cloud computing deployment models. You have a cloud deployment, you have a hybrid deployment, and on-premises deployment. What do you mean by cloud is you're hosting all your applications in the cloud service provider environment, AWS, Azure, GCP, Oracle, or anything. But certain customers, certain organization, or certain line of businesses do not permit to host their application on the cloud because of their compliances, legality, and so on. They need to ensure that data center is hosted on premises. But some applications which are non-business criticals can be hosted in the cloud. So what we try to do is we try to bridge them together. using hybrid cloud, using connectors to bridge the cloud and on-premises together. So AWS is a cloud service from Amazon. Amazon, you all know, it is by Jeff Bezos, and Andy is one of the new CEO of AWS and Amazon. So there is a story behind how AWS started this cloud services. Back then in 2000, AWS or Amazon, which is basically an online store, was scaling their application. They had built their application. They had multiple vendors into their application. The bigger and bigger the Amazon application grew, they had a lot of problems around scalability and so on. And any new requirement or any new integration used to take a lot of time. Henceforth, a team group of engineers in Amazon sat together. One of the key brains in Amazon is Werner Vogels, who is one of the CTOs of AWS. Went back and thought about how do we speed up the application deployment and the integration time. So the initial focus was around building their application and stabilizing their application environment. When they had a success story around it, they brought this concept into the market and they started selling as a cloud service. So now AWS basically provides infrastructure as a service, platform as a service, and software as a service as well, which provides services in the form of building blocks. These building blocks can be used to create and deploy any type of applications in the cloud. You can have single tier application or multi-tier application that can be hosted in the cloud. AWS is a secure cloud platform that offers broad set of cloud-based products. So one of the things to note is the footprint of AWS is across the globe, and it is secure. There are certain security responsibilities between the customers and AWS and it is clearly documented in the AWS documentation. What are the responsibilities from a security standpoint, from the customer standpoint, and what cloud service provider AWS offers. So what AWS provides is on-demand access to compute, that is servers, storage. So when you host your applications, you also host your storage and attach storage to it. Network, databases, and other IT resources and management tools. It is on-demand access. On-demand is highlighted. So whenever there is a read, for example, if I want to host an application as we speak right now, I can host an application on the fly. Offers flexibility. So you can scale in, scale out, offers high availability and fault tolerance as well. Pay only for individual service you need for as long as you use them. So it's kind of, you're going to pay for the calls which you're going to make from your cell phone and how long you have used your cell phone. So it is pay for the individual service you need for as long as you need them. AWS services work together like building blocks. You may have multiple AWS services. You can glue them together to build your solution. See, this training session is all about architecting. There are various services. How do you glue them all together to build your solution? And how do you architect it? When you say architect, it's kind of building a house. When you build a house, an architect puts a plan and he takes care of high availability, fault tolerance, and everything. How should your water enter into the building? How should it exit out of the building, right? And doors, security, everything is taken care by the architect. So that's exactly the role what you're going to play or what you're going to do by learning these services and by learning this technology. So there are various applications which can be hosted on AWS. You can host a website. You can share media. For example, you want to share a documentation to a group of your audience or to your team members. You can do that. Social media and application. Content delivery and media distribution. Basically, like I said, AWS has a global footprint. If I am accessing the application from India, the application which is hosted in US, there might be a slight delay. But what if I cache that information in India region? It becomes faster, and that specific content is delivered from India region. So we have content delivery and media distribution services. It offers storage and backup and disaster recovery, academic cloud computing, search engines, and social networking. So when you think like a developer thinks always about building their applications and hosting their applications. With AWS Applications allows the organization to use familiar programming models, operating systems, and database to host their application in the cloud. From a developer perspective, he would build an application in Linux platform with Postgres database. Now you may have a question, does Postgres database is available in the cloud? The answer is yes. There are a wide range of database offering provided by the cloud. Cost-effective services, fast deployment, add, remove capacity easily, and scale in, scale out without disturbing the services. Lowers the total cost of ownership. So you're not paying upfront to host your application. If you want to do a prototype or pilot an application, it's simple. Host it on cloud, test it. If it works, if the pilot goes on very well, put that into AWS cloud infrastructure in a bigger deployment. If your employees do not like your application, you can discard it. And the cost for that pilot is bare minimum. Offers centralized billing management. When you host your data center, you need to work with multiple vendors. Somebody who is selling racks, somebody who is selling AC, somebody who is selling virtualized hypervisor. But here it is all centralized. You are paying for what you use. So you host your application. It is being hosted for 30 hours. You pay for 30 hours. And also offers hybrid services. For example, you may have certain database information hosted in the on-premises data center. By gluing your cloud data center and on-premise data center by hybrid capabilities, you can have your cloud resources talk to your on-premises data center and on-premises data center talk to your cloud data center. Here are a few services which are available in AWS. I think there are more than close to 150 or plus applications. I can't remember the exact numbers. Quick Google search would get you the answer of number of services AWS offers. These services are incrementing every now and then. Every now and then services are incrementing, all right? So the foundational services are compute, storage, and networking. Compute, storage, and networking. Just give me a quick minute. All right. So we're going to talk about these services. Like I said, there are services incrementing day by day. So there are services in blockchain, gaming technology, media services, robotics, artificial intelligence, machine learning, IoT, and so on. There are countless, or there are many services which are offered by AWS. The core services are, from a network standpoint, it is virtual private cloud, Amazon virtual private cloud. From a networking standpoint, when I say networking standpoint, you all know IP address. Can I get a yes, no? You guys know what is an IP address? Can I get a yes, no, maybe? Anyone?
Yes.
Great. So assigning IP addressing, internet access, all those settings, networking related tasks is done by VPC service. All your virtual machines are hosted by EC2, Amazon EC2 service. What is EC2? Elastic Compute Cloud. Elastic Compute Cloud. Then you have storage services. Storage has multiple services. S3, Elastic Block Storage, Elastic File Storage, S3 Glacier, and so on. Then you also have database service. You also have database service, relational database services, and Dynamo DB. Then for access management, security is a bigger aspect in the cloud. So providing access to the application, providing access to the services can be done through IAM, identity and access management. So like I said, AWS has a global footprints. These numbers vary, okay? Some of them which are in the red, right? These are upcoming data centers in the cloud. The data centers in the cloud are spread globally in different regions. For example, we got one in India, and there was a recent announcement in Telangana as well. That is Hyderabad. I think Telangana, government of Telangana, it's basically hosted one of the data centers there as well, but it is spread across the world. Okay, we call it as each region will have multiple availability zones. When I say multiple availability zones, it is two different data centers. For fault tolerance and high availability purpose, you may have multiple availability zones. These availability zones may be distributed across different locations or different buildings and so on. We don't have visibility to it. All we knew are these are two different locations in the same regions. For example, Mumbai region may have multiple availability zones, which means 3 different data centers. You have some of them are being announced, and you have point of presence. Point of presence is basically for the content delivery and media services for caching. Okay, we call it as edge services and edge cache. An AWS region is a geographical area. Data replication across regions is controlled by you. When you say you may have an application hosted in region Mumbai, and you may have application hosted in availability zone A and availability zone B. Data replication between A and B has to be done by the cloud solution architect. The communication chain between the regions uses backbone network infrastructure, which means you can have the communication between the regions, between London region and Mumbai region. The communication between the London region and Mumbai region happens from the backbone AWS backbone network infrastructure. You can have, which means you can have your applications hosted across the geographical area. Each region provides full redundancy and connectivity to the network. Region typically consists of 2 or more availability zones. So how do you determine a region? Based on data governance and legal requirement. So when there is a GDPR requirement that, in the Europe region, which means data for Europe region has to be stored in Europe region only. So, which means naturally customers from Europe will pick up the data center or region in the Europe location. Another attribute which you can consider is proximity to customer. For example, if you have more users in India, you may pick up India as a region. But if you may have your user base in US, East Coast or West Coast, you may pick up accordingly. And another attribute is not all services are available in all the regions. There might be possibility that some of the services are available in region A and some of the services are available in region B. And in fact, there might be some cost variation between one region to another region. So based on these parameters, you can pick up the region. Availability zones, each region has multiple availability zone. Each availability zone has fully isolated partitions of AWS infrastructure. There are currently 69 availability zones worldwide. These numbers may vary. You see, EU region has availability zone 1A, 1B, 1C. This is one data center. This is one data center, and this is another data center in same location. Availability consists of discrete data centers. You may have these in single region. You may have multiple data centers. They are designed for fault tolerance. They are interconnected with other availability zones by using high-speed private links onto the AWS backbone network infrastructure. As a solution architect or as a administrator, you can pick the availability zone. AWS recommends replicating the data across availability zones for resiliency purpose. In fact, one of the CTOs of AWS says something, not everything would fail at one point in time. So ensure that you have fault tolerance, high availability, resiliency in your architecture. So AWS recommends your data is replicated across your availability zones. With that, I would like to take a pause and see if there are any questions so far. All right, guys, so I have something to take care of right after this call. So I'll take a pause here, and Praveen, do you want to intervene and wrap this session for today?
Yeah, sure, no, Raj, no issues. So guys, thank you for your time. So like post the demo, we'll have a call and we'll take it forward. Okay, thank you for your time.
Thank you, appreciate that. Thank you. Take care, bye.